It's called Spacelab, a mini-size, short-stay space station that will be carried into Earth orbit and be operated from the cargo bay of the Space Shuttle, beginning in 1983. Spacelab is a cooperative effort between NASA and the European Space Agency, ESA. The U.S. provides the shuttle transportation and the Europeans the reusable laboratory system. On Spacelab 1, scientific investigations will be prepared and carried out on a shared basis, a true multinational project involving 13 countries. Here at NASA's Marshall Space Flight Center in Alabama, crews gain experience in a realistic mock-up of Spacelab. 6 people will operate the science instruments, Spacelab systems, and the orbiter itself. In addition to NASA's pilot and mission specialist astronauts, 2 non-astronaut scientists, known as payload specialists, will for the first time have an opportunity to operate their own experiments and those of fellow scientists. One of the payload specialists will be a European and the other an American.
As a scientist, I'm interested in Spacelab because it affords me the opportunity to conduct research in an environment that is free from gravity. We at MIT are doing experiments in vestibular research. We're looking at the inner ear. We are trying to understand space motion sickness and the various causes of this malady that affects astronauts in space. For other scientists, Spacelab also provides a reasonable access to space with a module that is set up similar to an Earth laboratory. It has the ability to accommodate standard equipment that you would see in any Earth laboratory. So we're trying to make it attractive and feasible for scientists of many disciplines to conduct experiments in space.
Dozens of different instruments and experiment packages will be used in 5 broad areas of investigation. They are atmospheric physics, data that can help in the detection of pollution and weather forecasting, and Earth resource management studies that can be used for crop surveys and management of natural resources. Space plasma physics looks at little understood regions of the near-Earth environment that affect global communications and weather. Onboard astronomy investigations will study sources of radiation and measure the energy output of the sun, information that should help us better understand this giant nuclear furnace that affects us so greatly. The cloudless sky from which Spacelab can operate offers astronomers a chance to observe the stars and interstellar clouds of our universe with unprecedented clarity. Material sciences and processing, such as glass and ceramics technology, crystal growth, and the testing of new metal alloys in zero gravity could lead to new material processing techniques. And finally, life sciences, studies that deal with the effects of weightless space on humans and the growth and development of plant life. Other experiments include attempting to make pure cell preparations for use in transplants, prepare concentrated antibodies to treat certain illnesses, and to purify vaccines. Spacelab shares the reusable aspects of the shuttle in that it can be used again and again with a variety of changeable instruments and tests. In the years ahead, Spacelab is expected to open up a wide field of investigation in the areas of science, applications, and technology that will increasingly bring space down to Earth.